And we're back with a transportation problem. This is also borrowed out of the book. We have a distributor company, Gene Company I think is what it was, and they are moving at the very first problem a set of cotton bales from some farms in rural America to port cities. Eventually those port cities will ship the cotton out internationally, where they will be processed into jeans and then shipped back, I believe. So it's a several step process, but all we want to worry about right now is getting that supply to meet the demand going out of those ports of call. So before you do anything with any transport problem, you always first need to check what your situation is. And by that I mean, is there enough supply to go around? If there is not enough supply to go around, you have to change your plan of attack. If there is, then you'll try and make everyone happy and not ship out any extra. If there is not enough supply, then you're just going to try and get as much stuff out as you can. And so the constraints will change based on that situation. But I digress. So we need to check how much supply we have available and how much demand we have to try and meet. It looks, without really doing the arithmetic, that we have a lot more supply than demand. But I went ahead and added those up for us. And so this is the same table again. And the supply added up to be 103,000 units, 103,000 bales of cotton. And the demand added together to be 71,000 units. So we definitely have enough supply to meet every demand, which means that our constraints should be looking like this, more or less. Right, at each city that is a supplier, the amount leaving that city cannot exceed, it can never exceed how much supply you have. And conversely, the amount going into each city, because we can meet the demand, we should meet the demand. If the situation were reversed and we did not have enough supply, then this instead becomes an equal sign, or maybe a greater than or equal to sign, but realistically it just needs to be an equal sign. And if we could not meet all demand, then it would be impossible to use this constraint, and instead we will just use less than or equal to. In essence, meaning get as close to as you can. Alright. So let's get this information entered into Excel. And now you do have an option. You can either use my template or you can use the QM template. It honestly makes no never mind. Let me go ahead and reload that though. And now that you're a little more advanced, this is now the 2-star video instead of the 1-star. It's actually going to be the case that you could use QM on a assignment problem as long as you actually use the appropriate module. For weird assignment problems, you actually want to go to the transportation page. Alright, so for this I have, refresh my memory, 3 origins and 4 destinations. So let's get this pulled up here using this. So my origin areas is Arkansas, Mississippi, and don't tell me that's Michigan or something. I don't trust myself. And then Texas. And this is going to Houston, Savannah, New Orleans, and Charleston. And the available supply is 31, 45, 27,000. And the demands are 26, 19, 14, and 12,000. Should I use the... I'll do this. And I'll just get a decimal value at the end. Anyway, the costs were listed. So I'll get those typed in there real quick. And I think that's all we need to set up. We just now need to figure out how to assign are shipping routes, which is why shipping and transportation problems are basically identical, but I digress. Run solver, and we get these values as our solutions. I feel that maybe I should use thousands to make sure I've got it all working out to the nearest thousand. Or the nearest unit, sorry. And once we run solver again, okay, it actually does work out to be to the thousands. How about that? So that is a solution. It's going to cost $1E6. That's a little awkward. Okay. A little better that time. That looks to be $1 million. So to get all this cotton moved everywhere, it's going to be $1 million. Which sounds like a lot of money, and well, it is. But at the same time, if we were to take this problem all the way to its conclusion, which is, I think, 3 legs after this, you start to see just how many pairs of blue jeans all that cotton turns into, and how many tens of $1 millions they can expect to get in revenue and more than offset their costs. They would definitely have ample profits going through. So that's how you would set up this application for a transportation problem, and also by extension a assignment problem. It's just instead you would have appropriate supplies and demands here. But to show you how to set up this for it, we would again have 4 jobs: Houston, Savannah, New Orleans, Charleston. We would have Arkansas. I don't trust myself. MII I think is Michigan and Texas. We will delete all these extra actors out. And we will also do another one down here. We will add in our shipping costs per unit, per location. We will then, with that done, start changing what's going in here. So these columns now represent supplies. The least that can go out of every city, because supply exceeds demand, is their respective supplies. So had the situation been reversed, where we did not have enough supply to go around, we would also type 31,000 into this column, 45,000 into this column, 27,000 here. But that's not the case, so we don't actually need to ship all that out. Meanwhile, over here, we could put this as our maximum demand per location, and that's fine, but really that needs to go up here as well, and we don't truly need a maximum. We do need this minimum though, and that's because there's enough supply to go around. Every order can be filled, and so we are going to fill it. That done then, let's toss on solver, run this through, baked in results. We do have a solution, and we get the same results as before. Arkansas ships only to Charleston, Texas ships only to Houston, which isn't that surprising considering that Houston is in Texas, and Mississippi hits the other 2 spots. So there we go. Transport problems taken care of in 2 different ways. So let me know how this is going. And up next, we'll start tackling something a little more complicated.